Hello and welcome to the Fall 2025 Web Development Technologies course. This is Jim Kaufman with Rankin Technical College. So we're in week 13 now, already day 60. So actually, I think it's like 79 days in total here. It's just usually it's about 80. Sometimes it's a little less. Just depends on how things fall. I think it's like 79 or something. But so this is day 60, and we got less than 30 days left in the course now. This will be the last book chapter we'll be going over. This is all about creating custom objects, about properties and methods, and then I'll go ahead and I'll walk through the week 8 assignments. Just really the hot. There's not much I'm going to say about that. Maybe it can help you a little bit more on the custom objects homework, and then the other book stuff and written tests is obviously just the same things you've been doing. So not much I'm going to walk through on that. So let's go ahead and get started. Okay, so many programming languages have some object or are object-oriented programming languages, and JavaScript isn't kind of what I would say a true object-oriented programming languages, and because it's a little bit different, but for the most part, it's still kind of considered an object-oriented programming. Uh, is a type of object-oriented programming language. The ones that are really kind of I would consider as true is ones like C Sharp, C++, Java. Those would be considered truly object-oriented programming. JavaScript's just a little bit different, just how it was created. Okay, but it is the concept of object-oriented programming is it's a programming approach that organizes code around objects. Okay, they're reusable software components that combine data, which is properties. Always remember that. Properties are basically data, and then methods are functionality, right? And it combines them into a single unit. So there's 3 types of JavaScript objects. There's the native objects, and we've already used them. The array. We use the date object, we use the math object, we use the string object. These are all native objects that are part of the JavaScript language, right? They're called native objects. And then we have what's called host objects. Host objects are based on the browser, right? You have your window object where we can do alerts and prompts and confirms and things like that. Also, we looked at where we did some navigation type stuff, the history and things like that. Then you also have your document object model, your DOM, right? That's part of the browser, and that's considered another host object, and also form as well. And there's others that are not as popular or needed for the most part. And then there's custom objects, and custom objects are objects that you create yourself as a developer, right? Now, it's a good thing for you to, when you go throughout this application web development program, is to really learn about different object-oriented concepts, and especially really for a programming language to be object-oriented, it has to have certain things, okay? And one of them's encapsulation, and then there's inheritance, okay? And then there's a couple others as well. But, to be a true object-oriented programming language, you have to have these different things, right? So encapsulation means that all code and data needed for an object are contained within the object itself, okay? The code and data are hidden so they can't be accidentally modified by other programs. So if you write your code correctly, you create an object. It can't be can only be accessed in certain ways. Okay, and by writing your code a certain way, you can prevent your data from being changed or manipulated. Okay, objects expose what's called an interface And these are the properties and methods that other programs can access and use. Let's look at object literals. So an object literal is a standalone object created for a single purpose. So, let's just say that you've got a web page that where you've got a list of different students or whatever, and you click on one of them, right? You click on one of them, it's going to bring back one record. And in that case, you may have a single object, right? Now, when you have something where you may have multiple objects on a page, let's say you had multiple persons on a page, you'll want to kind of do it maybe a different way, okay? And we'll look at that here in a minute. But this is just showing you this is a basic object literal, and that's why it's saying for a single purpose is because you're just kind of really, you're just creating it, you're giving it the name, the age, the city, all within the object itself, right? All within the object itself. And so by doing this, and then you can access the properties of this object by doing the dot notation, person.name and person.age. And let's take a quick look at that. Let me get something set up here real quick. So let's just grab this. What am I wanting to do here? All right, so here I'm just gonna get developer tools up so we can kind of look at this a little bit. So I'm just gonna drop it right here in the console, just one way to do it. And then from there, you can just grab I'm just cutting and pasting from the document there. So that's showing John, right? And then grabbing the age, just person.age 30, right? And feel free to do that for different things you're looking at too. Just drop it in the console. It's a way to look at things, right? Then obviously you can change the person.age, right? So basically here you just got one person. And then these are choosing a number there. So obviously now it's going to be a 50, right? So you can obviously change it just by accessing the property of that object, right? Object.property, and you can change the values. Here we're looking at a nested object. Okay, here you've got an employee object, and inside your employee object, you have an address, right? And then obviously I kind of didn't mention this up here, but whenever you have a property, you want to have a colon there, right? You want to have a colon for each property. And so this is a property, but this property is another object because it has an open and closing curly brace, right? So this is kind of an object, a property object type thing, right? So this references and it has its own properties, right? So here, let's just drop this one in there. Oh, I have to grab it from over here. All right. And in this case, what we're doing here is you're going to access, say, city. You need to do employee, which is the name of the object, dot address, right, which is this property, which is an object itself, dot city, right? So that will access the city Boston there. And there you go on that. Okay, adding methods to an object property. So you can also add methods. And here you've got a calculator object. So always remember when you're looking at code, if you see in curly braces like this, if you have something that's defined with curly braces, then needs a trigger. Oh, yep, this is an object, right? And in this case, it's always going to be this. In these cases, this is a literal object, right? Here you've got a value property defined up here at the top, right? Then here you're got an add method, a subtract method, right? And a reset, right? And each one of these is a basically pointing, each has its own function, right? Where one is going to be adding, one subtracting, and the other is just to reset it back to zero again, right? And in all these cases, you're actually um, updating this value, updating this value in each case, right, based on whatever you're passing into this function, right? Um, so here you can kind of look at this example here, and so the first one is add 5. So you're going to come in here and it's going to return 5, right? Because the value is going to be 0. It's going to add whatever is a num and put that value, put the result back into the value, right? And then the next one down here is going to be a 3. The value already has a 5, so it's going to add 3. Then it's going to subtract 2, right? And then you're doing a reset here. Pretty straightforward. But I do kind of want to mention, maybe I'll wait a little bit because I want to show you a better example of what really this is, okay? What that really means. And I think if here in a couple examples from now, it'll make a lot more sense. But this keyword inside an object, this refers to the object itself. Use this to access the object's properties and other methods. Okay. Like I said, here in a minute, I'll go ahead and show you what that really kind of means in a little more detail, and actually just right here. So here is this is kind of showing you a little more modern way to create an object. Okay. So we got to greet and say age. We're doing that instead of what we did up here, where we did this whole saying it's a function and all of this. You don't necessarily have to do that. In later versions of JavaScript, and this is ES6 plus and later, this is kind of a shorthand method. You can just do greet like this or say age. Okay. So here you've got the name Bob, and then you're just printing out the name Bob here, and say age. Hello, I'm Bob. Yeah, well, they ain't doing anything with age, but that's okay. You'd have to set the age in there. But, okay, let's move on. Creating objects with a new object, okay? So in this case, this is another way to do an object, right? By creating, just use the new object. You have to do it just like this, right? This is a built-in JavaScript object constructor. By doing new object, so person now is an object, then you can add things to that object, add properties, and here we're adding a name and an age, Sarah 25. Then we have a greet method, okay? And then we're printing this out, right? Pretty straightforward here. This is how it's adding the method greet person.greet. Okay, limitations of object literals. Object literals are not reusable. If you need multiple similar objects, use a constructor, functions, or classes instead, okay? So here we got object classes and constructor functions. So an object class is a template for creating multiple similar objects. You define a class using a constructor function. So this is creating constructor function like this. Okay, so here you've got a person. And then and here you're not embedding the different people's names and ages, right? So you're basically just creating this constructor of type person. It has a name and an age, and it has a greet function. Okay. Now let me explain to you kind of what this is. So in this kind of case, what this means is actually lists this. What you're doing is creating, real quick, you're creating instances of this object. Here, let me just make this a little bit right now. You're creating instances of this object. This is an instance, and this is an instance. Okay, so you have like two instances of this object. You could create 20 of these, okay? And it's going to use this, right, kind of as a blueprint to create, this is kind of a blueprint to create these objects, right? And so here's creating one object, and here's creating another object, okay? It's calling the greet function on each one of these, right? But these, it's passing in these properties, right? And when it passes in these properties, it's going to create a new person object, okay? And this new person object that has John and 30 is the owner of, kind of the owner of this. This makes this object owns these properties, right? Whereas this one here owns these properties, okay? So this all has to do with kind of like who kind of like owns it, and it's the instance of the class owns this dot name, right? That way, when you create it John, right, person 1 is always going to refer to this one, right, with John and 30, right? This one's always going to return, this person 2 is always going to return to this person object that has Alice and 25, okay? So that's what kind of this does. If we got rid of this, you would kind of get an error here. Let me kind of actually show you that here. So let's just run this the way it should be. Let me grab this real quick. All right. Let's clear this. Let's refresh this. So now we've defined that constructor. And now I'm going to create that object, and we're going to create this other object. And then so then person 1 dot greet, I am John, I am 30 years old. It's kind of what we expected, what was over here. But let's just say instead of, let's get rid of this and see what happens, okay? Let's get rid of this and see what happens. And let me clear this. Let me go back up here. And, whoop. I don't want to do all of that. Probably would have been easier to do this a different way, but that's okay. Get rid of all these this, and let's get rid of this, let's get rid of that. Now if we run this, that worked, but now if I want to go ahead and create a new object, right, that should work. Okay, now when we do a greet though, uncut is not a function. Person 1 dot greet is not a function because it has to like bind it. What this does, that list keyword is going to bind this dot name, which is the name, which is like the John here. I'm looking over here on the right hand side. The this dot name binds, okay, it's going to bind this dot name to John, right? And then the second object, it's going to bind this dot name to Alice, okay? It's got to bind it. And so, and the same thing with the greet function, this dot greet, right? It needs to bind this to this object, and it uses this to do so. Without this, it's not going to bind it, okay? It's all about binding. All right, let me show you something else I kind of want to show you here. I'm going to just grab all of this again. Okay, and so then here's printing out our hello to John and hello to Alice. I just want to show you, you don't have to be an expert in this, but just kind of show you what happens is really when you create these objects, where are these objects at? They're in memory, right? They're in the browser memory, right? So let's just go look at them just for the heck of it here. Let's just go look at them. So what you can do is you can go to here's the console. We go to this memory tab here, right? And we come down here and look at take snapshot. Okay, this will take a snapshot of what's called the heap. And as you progress through this program, get in the second year, it's probably a good idea if you understand some of this heap stuff and how things get stored in memory a little more. And, you know, obviously we'll worry about that in the future. But for right now, just remember that, you know, objects, JavaScript objects and related DOM nodes get stored in the heap, okay? So we're going to take a snapshot of this. And now we had for our console here, we had what? We had person objects, right? So what you can do here is we can type in person. And you can see here's your two objects, okay? And so this is how this is stored. This is stored at a different, this little @ sign. I don't know how well you can see this, but this is stored in a memory location, right? This is stored in a memory location, right? And every time you create a new one, right? If we created another one, if I create another one here, it's going to create another object. Okay. Now I'll have to do another snapshot over here to look at that. But so now you'll have your third object here. But let's just go ahead and see what we currently have here. We got our two. And let's look at these numbers. So our first one was what? Alice. And it was, remember the location is 67487. So let's go back to our console here. And that was Alice's. So let's look at that again. I'm sorry. Yeah. And as you can see, it actually stored, even though which one was first? We actually created John first and Alice second, but it ended up it's in a different order. Actually, it is a later one. This is the most recent one. This is the most recent one, which was Alice. Obviously, I created that other one after that, but we'll see that here in a minute. But let's change Alice's name. So here, I'm just going to do person2. And then I'm going to have that equal to, let's just do that, Jane. And I'm going to enter here. And I'm going to go ahead and go back over here to the memory page. And I'm going to get rid of this. And I'm going to take another snapshot. And then let's go look at this. And we go look at that object. And why did it not do that? I'm not sure. I don't know what I did wrong though. But we got Ted and John now. You know, I don't know what happened to Alice, but we got Ted and John now. Ted's latest. That was a little bizarre. I'm wondering what happened here. You know, person two's got to be here. Oh, I see what I did. I messed that up. I reassigned a variable. I took that variable. I didn't do that right. I needed to do person.name, right? I messed that up. So here, let's just do this now. Since we're here, let's do ted.name. And I did want to just kind of look at our things here. So we got Ted, our numbers here. Ted is 151225. Let's go here and change our person3. Let's change our person3.name. Yep, .name. now this will work. Okay, and what's going to change him to Joe? So if I come back over here to memory now, I'm going to have to clear this and get a new one. Take the snapshot. And let's look for person here. So as you kind of notice that Ted, even though Ted is now Joe, but the object stays the same. So that object will stay the same. If you sit there and keep like if you reassign strings, let's just say string one equals, you know, high, and then you go and do the next line and do string one equals by, it will actually create a brand new, you know, and strings are under the hood are actually objects themselves. It will actually create a brand new one, right? But when you're using a object like this and you're using this constructor, when you create an object, it's going to stay that, and you can manipulate that so that that object's going to stay in memory until you get rid of that, right? Basically, all you can do is in a browser, you refresh the screen and that object's going to be gone, right? So, especially when we're using the console to create them. But just kind of pointing out that, you know, these are how the objects are stored in memory. They're stored in a heap, okay? And they have a certain location, right? All right. And so always remember, though, this, whenever you remember this, kind of this is always owned by each object. Each object has its own properties. Whenever you use this, it will have its own properties, right? So the person has its own name, its own age, and in this case, actually, it has its own greet function as well. It will have a copy of this. Okay. Now, this isn't always the best way to do this because, you know, here you just got a couple little simple example objects. But if you've got a page, let's say you've got a page, it's a big table of a lot of data, and you're creating multiple objects. Okay. And the way you'd actually get the data for the objects is usually things we do are just kind of little examples. Is usually you've got like a back-end service that you're calling, some data's coming, and your JavaScript's looping through all that data and creating objects out of it for display purposes and so forth. And you may manipulate that data and resave it. You know, there's lots of things that can be done, right? But a lot of times the way you get data is, you know, hard-coded data. A lot of our examples, we're just kind of hard-coding data in. You know, in the real world, when we really start getting into more complex systems, you've got data on a back end that's being called or manipulated and resaved, right? So you could have, you know, especially like I said, you could have a situation where you've got, you know, a big table of data, right? When you have that big table of data, having a this dot greet to having a function using a property like this, you're going to have each one's going to have a copy. So this person has a copy of each one of these. Okay, this person has its own unique copy of all of this as well. Okay. It's not sharing it. So a lot of things we did before with functions, we just shared functions. You know, we created a function, we called the function, did something, and it was done, right? But with objects is a little different, right? Especially when you're doing things with these constructors and using the this keyword. So each instance of an object, this is called an instance of an object, has its own properties and functions. Okay. Okay, here's just a more complex constructor example. On a car object, you got a make, model, year, mileage. Pretty much the same here, though. Not much different here. Just has a few more properties, and you're just kind of doing a little bit more here. But it's really not that much more complex. And here once again, so you know, new car's going to have, so you can create multiple objects here, passing in a different make, model, and year. So you're going to have different objects, right? And each one of those objects, we're going to have its own set of properties, and it's going to have its own set of functions. And basically the reason it's going to have its own set of functions too is because it's using a property, giving it a name equaling a function here, right? So it's going to, since you're using this keyword here, every instance of that object's going to have its own copy of that. Okay. Combining object classes. Okay. Well, so here you're showing you've got a card constructor, and here you have a deck constructor. Right. Your card has suits and ranks, and your deck has a cards. You know, this is a empty array. It has different suits and different ranks, right? And it's actually looping through everything and pushing this .cards.push. It's pushing new cards to this card here. And then it's got a little shuffle command. And this is doing a random, where it's just kind of grabbing a random card. And let's just kind of drop this in there just to take a look at this. Why not? Okay, so here's going to be a card constructor. And then here's a deck. Actually, let me just grab all of this. So once again, always remember all this is going to be holding on to, even though you got suits and ranks here, right? Each object to create, each object you use when you instantiate object, it's not going to have cards and suits, right? Well, it's not going to have suits and ranks. I'm sorry, suits and ranks, right? It's not going to have that because it's not going to have what I say, this array. It's not going to have these arrays. This is only within deck. Cards has a this on there. So any instantiated object is going to have that. But part of this little program here is actually pushing your suits and your ranks to your cards. So that all your objects that instantiate this are only going to have cards, right? And well, it's going to have a shuffle and a deal though too. Because you got this keywords here, right? So let's just go ahead and create a new deck here. And then on that, let's shuffle our deck. And let's deal our card. And then let's see what our rank and our suit are. Okay, so in this case, what we have deck equals a new deck, right? And then we did we shuffled our deck, right? And then we created a card object equals deck.deal, because it's got a this keyword, right? Card can access this, has a copy of this function, right? Card has a copy of this function. So then it can do a deck.deal, okay? And then we are doing card.rank and card.suit, and this time it would return a 7 of hearts. Obviously, you just run this again. It's going to show that. Oh, yeah, you got to shuffle your deck again. So, each time. So you get a different one back if you do that. Okay. I don't know if that really helps with a lot there, but now let's talk a little bit about prototypes. Every object has a prototype. And that's one thing that's kind of a little different than in JavaScript, than other programming languages, such as C#, C++, Java, etc. JavaScript has this concept of prototype, and a prototype is a A template containing properties and methods shared by all instances of the class. Using prototypes is more memory efficient than putting methods in a constructor. Okay. So here you got an example of a person object, just like we did before with a name and age, right? You've got this keywords. So whenever you see this, always think to yourself, every instance of your person object, when you create an instance of your person object, like down here, when you're creating these instances, it's always going to have, it's going to bind the name and age. And so it's going to have access to name and age. It's going to have its own properties. It's going to have its own properties for each one that's defined. And in this case, it's going to have its own name and then its own age. Okay. Now, with using a prototype, as you can see, we're using this keyword prototype here. So here's our person object, and every object, it said up here, every object has its own prototype. Every object has a prototype. So by doing .prototype on your object, you can create a function, right? You can create a method. So in this case, call a greet method, okay? And you set it to this function here. Now, one thing though that's different is because this .name, right? This .name is binded to each instance, right? It's binded to each instance. So the way this kind of works is, even though before, remember when we created some of those methods and stuff, we had the instance had its own copy. And every instance is not going to have its own copy. Okay, it's going to be shared. This is going to be shared by all instances. Okay, so this is much more efficient, especially if you're creating, because it takes up a lot of memory. This is a pretty simple little method here. But if you have a substantial method, and instead of just having an object or a couple objects on your page, you've got 200 objects or 400 objects. Maybe, like I said, maybe you've got a big long table that you're scrolling through, and it has all students in the AWD program, and so you've got this whole list of all the students in the AWD program, right? So you have a lot of objects. Well, there you probably don't want to, when you start having lots of objects, you don't really want to have a copy for each one. It's just not efficient. A lot of things we do, it doesn't really matter, but when you start working on some sophisticated applications, it's going to be important. And it's important for you to probably understand that well, so that you can kind of explain that to a potential employer, or anybody you're doing any work for, because, it does start mattering when you got something very sophisticated, right? Can really slow something down, right? Slow a page from rendering. You know how it is when you ever go somewhere, if something doesn't display pretty quickly, you just close it, move on. Right? You don't stick around. You click something, and all of a sudden it's loading slow. Most people are impatient. We all are. You just kind of get out of there and go try something else, right? So when you've got something substantial on a page, it takes a while for that to load. And so there's no reason, and all this stuff also gets stored in memory, right? So you're using up memory, and as you use up memory, that slows things down as well, right? So by doing this, you only create one copy of this and one copy of this, which will be shared by all instances, okay? But each instance will have its own name property and its own age property, okay? And if we probably actually went and looked, how I was looking at the memory tab in there. If we create a, if I did it on this thing here, it would show all of these functions. Well, you're only doing one, but let's do one like this here, where if you created multiple cars, it would show this, and then it would also show in that memory, when we looked at memory tab, it would have this. So if you created 20 different car objects, you would have you would see that this dot drive, just like you would see these other properties, you would also see this one. Okay. Um, when we're doing it like this, though, right? And you looked at these objects, you're only going to see name and age, right? So, well, why don't we just go look at that real quick here? Let's do F12 again. Let's refresh this. Where are we at? Okay, let me grab this real quick. So there's our person object. And now let's add our methods. Let's just let me grab each one of these. And this is a prototype. And you kind of notice how the console treats things a little different there. It's because this is what it's kind of doing internally. Okay. So now I'm going to create an instance of John. And I'm going to create an instance of Alice. I should say instance of John. Another person, another instance of person with the properties of John, and another instance of person with the property of Alice. And so now if I go to the memory here, and I'm going to take a snapshot of this. I'm going to go up here and go to person again. And so here, you're just going to see name and age. Okay, you are going to see this prototype though, right? This prototype, right? It has a reference to this prototype. Okay, it has a reference to it, but it doesn't have a copy of it. It's not the same as this, where this actually has a copy. Okay, this has a reference to the prototype, but a reference to the prototype, a reference to a function like this is not the same as having an actual copy, right? Here, this has a distinct copy of name and age, okay? All right. All right, where were we? So why use prototypes? Prototypes methods are defined once, shared by all instances. Okay. Easy updates. You can change a prototype method to update all instances. Okay. You can change one. You can change a prototype. It'll update all instances, which makes a lot of sense. Because if you created you created new objects. Yeah, well, I don't want to cause a little confusion there. But okay, so but you change the prototype method, and it'll update all instances. Better performance. It's less memory used per object, and so that's probably the most important part of this. Is less memory used per object. So extending built-in objects. This is just add a method to an array. It's just showing you some other ones here. Add the method to a string prototype. Yeah. So this is already the existing arrays prototype in a string. So it's kind of really telling you that you can actually extend objects that are already created. So these are those built-in objects like string and array. You can actually build upon that. You can extend those built-in objects. But extending built-in prototypes can cause conflicts with other code or future JavaScript figures. And so use them only if you need to. In most cases, you won't. But just mentioning that you can actually extend existing, because a prototypes used by all objects have a prototype, and so you can actually add things to that and update things. So a closure is created when a function remembers the variables from its surrounding scope even after the scope has finished executing. Okay. So most of the time when we've created functions, we run a function and then it's done. When it's done, and that's it, right? So this is just showing an example where, um, so you're running outer here, and then count is private, can't be accessed directly. Let me look at this here. Yeah, error. Yeah. So this is a private variable. I gotta see how this is working here. Real quick here. Let me just grab this and grab all of this. Okay, we've got outer function, inner function, 1, 2, 3. Okay, yeah, I see what they're kind of saying here now. So count is not defined. Yeah, so here actually inner has access. Okay, inner has access to this count. Okay, this inner has access to this count, but once you're gone from there, you ran counter. You're running this multiple times. This is just create a new outer one. 1, 2, 3. It's actually every time you run it, um, it's actually iterating it. 1, 2, 3, right? But then if you try to access count, you can't because it's private. It's a private variable here. Okay. Practical closure example, counterfactory using closures. Let's see what's saying here. Counter.getValue. Yeah. Well, it's just showing you, so you can't access the private, so you can't access this count, right? So a different way to access this count is using, like here, you got a function called getValue, and getValue can access that count. So you can sit there and call all these other different functions, and as you're calling these functions, it's going to continue to change. Well, you're going to have a start, right? When you call create counter in the first place, you're going to pass this variable. It's going to set this to that, right? Then it's going to start. Then depending what you call after that, right? This is an object, so this object stays in memory, right? So so you can continually update this count, and that's what you're kind of doing here. You're starting with 0, you're incrementing it by 1, right? And then you increment it again, it's going to be 2. Here you take counter 2, which you started as 100, and you're doing a decrement. And then if you want, you can just use this to get the value of that, right? So that's will actually get the value of that count. And always remember, this one is a separate object from this one, right? So this object is not going to affect the values, the properties of the other object, right? Closure to event handlers. Let's not look too much at that. Let's talk about little public, private, and privileged methods. So define on a prototype accessible from outside an object. Okay, so public methods are, here's defined in a prototype, and these are accessible to outside the object. So you have a bank account. And you're putting a prototype on there. Get balance, just going to return this balance. It's going to have its own instance. This is just kind of everything we kind of done before, right? So you just can see that you've got access. You can, this is the object itself. You can access this without being in here itself. That's all it's saying. It's public. Here you've got a defined inside the constructor, only accessible within the constructor, right? So here you got a private balance. What makes this private, right? What makes this private is here you're using this keyword. So everything has its own copy, right? So every time you create a new object here, you've got your own copy of this, right? So you can access this. In this case, you don't have a this keyword. So this is not accessible, okay? This is not accessible. This is not accessible outside of this constructor, okay? Now, if you could always have another function, that could help you with that, but you don't have access. And we were talking about at the beginning kind of encapsulation. So this is kind of really an idea of encapsulation. So you're encapsulating this data so that certain things can't access it, right? In this case, account dot, when you create this account, you can't get the value. You can't get that value. Here, let's just do this real quick. Let me clear this out. This is the bank one. Let me go grab that. So we'll get a function. Nope. Okay, we have a bank account. Then I create an instance of this. This may not work quite like I think it's going to work. So yeah, it did though. Okay, yeah. So account.validate amount. Well, also you don't have this word on validate amount either, right? So you don't remember before we had like this, and we could actually. So you can't access validate amount, and also this is a private variable. So it's a private variable and a private method, right? So you can't access either one of those, right? Yeah, so here we go. Let me see what will, well, that will return that. What's account? Create the bank account. All right. That's okay. So privilege methods. So defined in a constructor with this can access private variables, but are also public, right? So here we're still got a private variable. Here we got a private method, right? No this. So these are considered privileged methods, can access private data, okay? So this is a way that, since this is within the constructor here, right? Since this is within this constructor here, since it's within this constructor, we can access balance, right? Because this is within that itself, right? Privilege methods can access private data. So this, and then since you're calling this .get balance, okay, you have access to this, and since it's within the constructor itself, it will have access to that balance. So in this case, can't access the private variable directly. No, you can't do that. But if you create a bank account object, and then you do a get balance on it, right? 500. And you do a deposit. It's just showing you each of these. But for get balance here, you have to be able to to access the balance, but it's only accessed within this constructor, right? So this is showing you how you can get the balance by not having access. But the whole point here is you're making it that data. You're controlling how that is accessed, right? You're controlling how that accessed in the program, right? So you have to use that method to access that data. You can't change that data, right? If you can have access to that data, you could possibly change that data, right? If you had access to this individual balance, some other program, you could create an instance of it, then you could change it, and maybe you don't want it changed, right? By making it private, you prevent that from happening, and that's all about encapsulating, okay? Here's what's called a prototype chain. So a protocol inheritance allows one object class to inherit properties and methods from another, creating a hierarchy. So here you've got a base class of animal, okay? And you're creating a prototype. Remember, a prototype's always going to be a standalone. It's going to be outside of the main base class, or whatever class you create. So in this case, you got an animal prototype. It's always going to be outside of that. And you've got an eat function. And remember this dot name. Whenever you see this dot name, that means each instantiated object has its own copy. Okay, has its own copy. And now what we're doing here is we're creating a subclass. The way we create a subclass in JavaScript, you just create the name of your object, and then you can use what's a dot call. You do a dot call on the superclass, your base class. And this is animal, so animal.call, passing in. So here, dog has a breed and a name, okay? Animal only has a name, right? So basically here, when you do animal.call, you do this. This is actually going to use this name, right? And then breed, breed isn't even going to be used here, right? Breed is not even going to be used here. I need to make sure this is going to work right. And it might. There's a couple things I'm kind of wondering about. So let's bring our base class here. And let's create our prototype. Okay. Call parent constructor this, calling this with name. Okay. I guess that will be right. So yeah, this sets up inheritance. So where were we on that? Dog.prototype, object.create, animal.prototype. So what you're kind of doing here is you're setting up so that the dog prototype extends or inherits from the animal prototype. Okay. And then from there, you can add a specific method, add a dog specific method on it. Okay. And in this case, you're doing a bark. Okay. And then we're going to create a new dog instance now. And now if we call my dog, let's see, my dog dot eat. Oh, it would help if I Buddy is eating, and the same for Bark. So in this case, you're actually calling kind of the eat, right, from the animal prototype, right? Even though you didn't create a prototype for the dog one, but you did have to do this, right? Object.create animal.prototype. So, all right. Prototype and change inheritance. Okay, more inheritance example. Kind of same thing here. You got a vehicle. In this case, you got a car and a motorcycle. All right, I'm not going to go through too much of that. Associated array. Kind of want to mention something here. So an associative array uses key value pairs instead of numeric indices. So a lot of times in array type stuff, we do array subset 0 equals this, subset 1, right? Use the numeric indices. So for associative arrays, in this case, like here, you're creating an associative array. An array is an object, right? So you're creating an associative array where you got a person. So you got a first name, a last name, an age, and a city, right? So this is basically an object, right? A person object has different properties, right? But you can access it in a different way, right? So you can access it with bracket notations like this. Person dot first name, okay? Dynamic key access, you can, well, it's just showing that you can change the name of the key. Whatever you wanted to call it, right? In this case, you're calling age. Key is age, and then using that variable. But basically, I think the biggest thing is just remember that for like associative arrays use key value pairs. The key is the property, and then value, right? Property is the key, and the names of and whatever string, whatever you give it is a value, right? Property value. For in loop, okay. So some loops are better to use for objects than others, right? Your traditional for loops probably not the best thing to use. What here you've got a car, you got a make, a model, a year, and then here you're actually just looping through this one car object. So this obviously just your variable declaration. So you're creating this yourself, right? This name is not in it. You're creating this yourself, and you're calling it key. You call this whatever you want to call it, right? But key, so you let key in car, right? And then you do, in this case, you do car dot key, and it's going to loop through this, and it's going to output make, model, year. Let's just take a quick look at that one. And we'll loop through that. So there you go. Make, model, year. So this is a different kind of a for loop. There's different ones. We were kind of using a lot of the traditional type for loops, right? This is a more and more a little bit more modern. So this is a for in, right, where you use a key and then you're gonna pass in your object as well, right? So just a simpler and easier way to access objects, right? Iterate through objects. Now, Jason, you're going to hear a lot more about Jason as you continue within this program. So JSON stands for JavaScript Object Notation. It's a text format for storing and exchanging data. It looks similar to JavaScript. It's kind of just been a decided on exchange format that's used by a lot of companies, a lot of organizations, a lot of others as well, to just as a way to exchange data. And so it's a common way that you say, oh, we're sending JSON, you know what they're sending, and back and forth, right? So this is just showing an example how you can actually parse. So here's your JSON object, right? JSON string, I should say. It's using a tick here, right? And it's just name value pairs. When you start dealing with a lot of data, this is very, very likely what you're going to be seeing. A lot of times when you call some backend function that's going to be returning a lot of data, you're usually going to have it in a JSON type format, right? It's not going to, this is just creating this, but this will look a little differently, but it's just going to be returning all this kind of data, right? And it'll have the brackets and stuff, but it'll be returning all kinds of data objects, right? Then what you do is you can parse it. In this case, you're taking a person, and you can parse this string into this person, right? And then just do person.name, person.hobby. Here's .hobbies, where you're getting the very first one, right? Or obviously you can always get the whole one and be looping through all of that. So just kind of showing you the different functions that are available on the JSON objects. Working with JSON data. This is using a for of loop. Okay, very, very popular for JavaScript, for JSON objects. So I'm not going to spend a lot of time on this, but JSON rules, keys must be in double quotes, strings must be in double quotes, no trailing commas, no comments are allowed, no functions or undefined values. Okay. So quick here, use a constructor, functions for reusable. This is basically this whole guide here. So use a constructor functions for reusable objects. When you're going to want to create multiple objects, best to use a constructor function as opposed to a literal object. If you're just creating a one-off object where you're just creating some object, you're going to be using it and that's about it, that's fine, or even a couple. But if you're going to be reusing an object, like I had an example where you may have multiple rows of maybe like students or something, where students have an ID, they have a name, they have an email address. That would be a student object, right? And you'd have multiple of those. So here, in that situation, you're better off with a constructor. It's best to put your methods on prototypes. We talked about that as far as memory for efficiency. That when you create, if you don't do it, if you just create these functions within the object itself, within the constructors itself, if you create those methods within the objects itself, then and when you're using this keyword, it's going to create a copy of each one, where a prototype is just going to you're only going to create one prototype method, for each method that you want. You'll create a prototype method that'll be shared between all instances of the objects, right? It's much more efficient. Use closures for data privacy. So that's where you can have you don't use when you have a private variable, you don't use this on there, right? But then you have to access that kind of a different way, right? And that kind of keeps it private. That's the whole idea behind encapsulation of data, right? Just tell you, for when you create constructors, you should use capital case. Just a naming convention for constructors. Use a capital case instead of using, a lot of times in functions, use a lowercase letter for your function name. And it's best to use a capital case for constructors, just so it sticks out. Use privilege methods to access private data safely, right? Be careful extending built-in prototypes like the ones like array and string. You can actually extend those and you can add other stuff to it, and be careful doing that. JSON's data is used a lot for data exchange. Usually when you make calls to external services outside of your page. Obviously in this class, we're really focusing more on the client side, not a full stack type where you got a front end and a back end. Usually when you're calling back end services and you're returning that data, you return that data in some certain format, and a JSON format, which stands for JavaScript Object Notation, is a very popular way for data exchange. Okay, and then test your JSON syntax carefully to make sure that you didn't, especially when you're sending data back, you want to make sure it's correct, because usually you might be sending it to other other companies, other things. You may be sending it, and you want to make sure you don't break their stuff, right? Quick reference here. This is how you create an object literal, right? This is an example of a constructor function. Probably shouldn't use the word class, but that's okay. Well, that's the name. They're just saying the name of the class you're giving it here. But make sure make sure it's a first class. First letter is uppercase, right? This is how you instantiate an object. This is how you can add to a prototype. This is what you use for inheritance, object.create. Okay. And then you have your parent prototype here. Okay. And so that way you can inherit the prototype of the parent. For JSON object, this is how you parse a string, right? This is how you parse data coming in. This is kind of the other way, or when you have an object. If you create an object and you want to turn that object into a JSON string, okay, this is how you do that, okay. So usually when you're bringing data in, you can't. So let's say you're calling a backend service. When you call some backend service, it's not going to send objects, right? It doesn't send objects. It's going to send string data. Everything's string data. Same thing like how we always did like form data and stuff. You can't send an object in the HTML to your JavaScript. You can't send an object, right? You have to send strings of data, right? All the object work is done, all the object work and that is done within your JavaScript, right? But the HTML itself can't. Same thing with over the internet, because you're using the same thing, your HTTP protocol. You cannot send you can't send objects like that for the most part using that, right? You're going to be sending string data for HTTP data, right? So when you get that data from a backend service, it's going to be a string of data, right? So you can parse that to create objects out of that. You can create objects out of that data, right? But then you may be going the other way. Let's say that you're creating objects. You can pretend you're working on the back end and you're creating. Once you start learning how to do some back end stuff, we're going to do a few things that you're going to learn when we do some node stuff. You can actually create objects and you can turn that into strings, right? By doing that, you stringify. Right? You take your object and it'll turn it into a JSON string, right? As far as loops, different kinds of loops, we were kind of used to more traditional type for loops, but you can, for objects and stuff, you can do objects and keys. So here, key is obviously a name that you're giving it. Same thing with val down here, right? This is a declaration with the let. You're giving it whatever name you want, but key's kind of popular to use, and so is value for that, right? So key, and then this is whatever object you're passing in, right? Whatever object you're using. So you're looping through it, and breaking in to key and value, and this is a way to do arrays as well, right? So key takeaways: object-oriented programming organizes code in reusable objects. Object literals are for single-use objects. Constructor functions create reusable classes. This refers to the current object. And so remember, whenever you say this, always think that this binds that property to your instance of your objects. So your instance of your objects are going to have properties and methods. Anything that starts with this, those those instances that you create will have a copy of those properties and methods if you use the this keyword, right? Prototypes share methods efficiently. So every object has a prototype, right? So you can create new prototypes, and you can share methods using the prototypes. Closures create private variables. We looked at the private variables where you don't have a this keyword on there, right? But you can access it by calling maybe another method. But remember, closures, really, the private variables are always about like encapsulating data, right? That's one of the object-oriented principles is encapsulation. For a programming language to be considered an object-oriented programming language, that's one of the things it needs to have. Inheritance is another, and there's others as well, but that's the only ones we kind of really talked about. You got to be able to use inheritance, and we had examples of that here in a minute. And so also, you have to be able to encapsulate data, and you can use that by using private variables. Okay. Public methods are on a prototype. Okay. Private methods are inside the constructor. Privileged methods access private data. Right. So you can create a method in your constructor that has access to a private variable, and to be able to get to that private data, your instances have to use that method that's declared, okay, to access that private data, right? Prototype chains enable inheritance. That way, we looked at that animal and that dog. So that's a way to inherit from a base class. Use prototype chains to enable inheritance. JSON is for data storage and exchange. And then we already talked about for loops and for of loops. Okay, so that's all I have on that, on chapter 8. We can go ahead and go through the homework. Okay, wanted to go over homework assignments here real quick. Well, specifically the hands-on test and then the custom objects one. So for the hands-on test, obviously put it in your hot 3 under your JavaScript hands-on test. Things I just kind of wanted to point out, this is kind of taken, we've done a lot of things. I know some of your book stuff that, uses the HTML and stuff, but here, you're going to be creating some of your own documents again, starting from scratch, right? So, you're going to create a login form. Here, in addition to that, we're going to be doing some back to Bootstrap, right? So you're going to have some Bootstrap elements that you're going to include, right? So use Bootstrap 5 to style the whole web page. And here you've got some Bootstrap related stuff for buttons and test success and test danger. And do want to point out, don't forget about the DOM stuff. So when you're creating these error messages, you're going to be using the DOM, right? You're going to have to create those using the document object model like we've done, right? So, don't make sure you do that correctly, and you're not using the built-in validations that are within HTML. You're going to be, creating your own JavaScript document object model. You're going to validate, you're going to write your own stuff to validate it, and then you're going to create these messages based on that, right? Um, I don't know if there's a lot for me to really talk about here on this. The biggest thing I just wanted to really point out, is the document object model stuff. And obviously, you're going to be using, you know, you're going to, each challenge below its own individual HTML page. So you have one page for each login page, a to-do app, whatever. You can call it to-do.html, and, your upvote, downvote. And, make sure you're using Bootstrap. So not a lot to discuss there. Here on this assignment, this is the JavaScript objects homework stuff. This might be a little bit challenging. No, other way, I'm not saying the hands-on test me. You're probably gonna have to rethink some things. It's been a while since you did Bootstrap and stuff, but might be a little bit more challenging. You got 4 different exercises, each worth 25 points. In your I'm going to make this in the homework. We have homework and labs. I wouldn't have to really worry about that. Each one, homework and labs, were 20%. I'm trying to even things up. We did have a lot of things that were classified as homework before, but a lot of our stuff's been classified lab. I'm trying to even it up so they're about the same. But so that if I only had a couple assignments being homework, I had a lot labs, then each of those homework assignments would be worth a lot more, and probably not the best thing. So I'm just trying to even up the amount of points that are in the bucket, so to speak, in the homework bucket as opposed to lab bucket. So trying to get that a little more even before the end of the semester. So under Chapter 8, under your JavaScript homework, go ahead and create a folder called Chapter 8 because there's not one out there now. So one thing I do want to point out is, so a lot of this stuff, if you kind of use the guide, and I'll actually put a link to that guide in here. That object guide is going to help you with a lot of this, okay? And actually some of this stuff, so this first one is a library book system. The next one's a student grade manager, a bank account, and then a vehicle inheritance. And actually some of this stuff was already kind of in the guide. It's a little bit different, but it was kind of doing some things that were very similar here. Let's see what we had here. So here's a car object. So we have a vehicle here. So here's a vehicle, right? And a car, vehicle in your car. So I'm not saying that you're just going to cut and paste exactly what's in there. Maybe some of it you can use, right? Maybe some of it you can use, but there is some similarity there that can kind of help you out to get started with some of these. So and just remember I was kind of trying to highlight these. I might highlight some more of these. See if I can add a little bit of stuff in here that might help you a little bit. But a privilege method, so see what a privilege, you want to search what's a privilege method, right? So you make sure you're using a privilege method, right? And you're going to want to say validation for a positive amount, right? You're going to check to make sure it's greater than 0, right? Validation for sufficient funds and positive amount. Let me know on this if you need any assistance. I know it might be a little bit challenging. Not a lot for me to really go through, I guess, here on this either. But I'll try to put a little bit more information in here. Obviously, I think that guide will help you out a lot. And obviously, you can use the internet to do some searching as well. So here, one thing I do want to point out. So probably just best to do it this way for something like this. Because really this is all JavaScript where you're really not displaying a lot of stuff. You're using console.logs. We're not really, but having a custom objects.html file. And then probably what's best is just have 4 different begin and end script tags, right? Have 4 different sections for each one of these, right? The other way you can, if you want to create separate scripts, but then you're going to have to make sure you include that in your HTML and for testing purposes. Whatever's best is fine. But probably the easiest way is to create this custom objects.html, and you just have 4 different, script sections for each one of these, right? Probably best to, add comments to identify each exercise. So maybe just at the beginning of that, you say library system, just, quick comment. But I'll try to, I'll add a link to the object guide for that. And I'll see if I can kind of point out some other things in here and highlight some things as well. So, yeah, please let me know if you have any questions about this objects homework as well. So, and I guess that's all I have. Take care and have a good day.